Hello. Welcome to Modernization Accepted, a podcast by Resolute Software. This is Mike Hines. With OpenAI's release of ChatGPT 3.5 in November of 2022, artificial intelligence, machine learning, big data has all of a sudden gotten a lot more popular and a lot more people are talking about it. Everything from solving everyone's problem to being the tool of destruction for everyone. The reality, though, is a little more mundane when you get right down to the nitty-gritty of how AI actually works. And today we've got Mike Koenig, a professor of computer science at Seattle University and alumni of Microsoft Corporation for about 20 years, who's going to talk with us about how artificial intelligence actually works and the data behind it that makes it work or maybe not work so well. Thank you for joining us, Mike.
Happy to be here. It's kind of fun to talk about this. AI is a very interesting area right now. A lot of people are wondering what it can do, where it's going to go in the future. Sometimes they don't wonder what it does weird or what it does wrong. And so I like to add in that AI doesn't solve all the problems. It brings a new set of problems. So it's kind of fun to talk about those.
It is fun to talk about those, and let's set some ground rules because not all AI is the same. We've got large language model AI, generative AI, pre-trained transformative AI. So what do the different AIs do? Can you walk us through that?
Absolutely. I'm actually going to start with something you didn't mention, which is what's called traditional AI. And everyone has forgotten about traditional AI in all the hype associated with the large language models or the generative. But let's start with the traditional AI just for a second so we can get a foundation out there. I happen to teach a class right now at Seattle University on AI fundamentals. And all the students show up thinking they're going to be using ChatGPT. And we sit back and be like, no, here are the foundations that AI are built upon. And what do we talk about? We talk about just doing regular percentiles. We talk about doing regular percentages and the likelihood of something. You have to go back and remember, if you flip a coin, are you going to get heads or tails, and how many times you flip in a row? What's the likelihood of getting 5 heads in a row or not? And the next toss, what's the likelihood that's going to be? That's back to the foundation of AI. It's built on these core principles of statistics and probability. Now, the probability is a little different. You're not trying to be probable about, is the next coin toss going to be a heads or a tail? You're trying to be probable about a question that's kind of vague and one that usually humans don't do a good job at answering. So, an example, in the class we teach, we do the old game of Pac-Man. And how do you write an algorithm where you can actually capture all the ghosts? What's the probability that a ghost is next to you based on your knowledge of the rest of the game board?
So we've been living with AI for decades and decades. This isn't new.
It's not new. The field of AI is actually quite old. There's a couple changes that have happened recently, and that's the fun thing to talk about. So if you go back and think about the fundamentals of AI, decision trees and probability, that's the same. And that's used in all the pieces coming forward. The difference is the amount of data that we can actually use to come up with and understand the different results we're looking at. And so you take the idea of a Pac-Man on a Pac-Man board for a second. If it's a 4x4 board, a person can pretty much calculate the probability of there being a Pac-Man ghost next to them, because they're like, well, there's only a set number of squares, or 16 squares, and there's 2 ghosts on the board. What's the likelihood of a ghost being next to me? That's doable from a human's perspective. Make that board 1,000,000 rows by 1,000,000 rows, and put 6 ghosts on there, right? And then ask Pac-Man to find the ghost in the least number of steps. A human can't do that, but a computer can.
So by adding a huge amount of data, what benefit does that? Arguably the Pac-Man model is a pretty simple algorithm to do it. You just have to do it on a massive scale. So what does massive data give a relatively simple algorithm?
And this is where it comes, the change in AI is actually kind of fascinating to watch. in the past, when I was working at Microsoft, for example, I worked in the natural language processing group. And so all of the natural language for Microsoft, the understanding communication, the spelling, the grammar, keyword extraction, all that was my team. And so I was kind of heading that up from the product side. And we think about it is we were working in what we considered medium-sized data models. And you're like, what does that mean? Well, a medium-sized data model might be millions and millions of examples. And so, for example, we would go through, we'd go through, like say, 100,000 PowerPoint presentations that we would find on the internet. And we would look at every single slide. And then from that, we would say, what's the most common bullet style? And we would say, oh, the most common bullet style of presentations is, I'm making this up, a triangle. And we're like, okay. And what's the second most common style? And the second most common one is a dark circle. All right, what's the third most common? Oh, the third most common one happens to be a square, just so we can get all the shapes in here for a second, okay?
Mm-hmm.
So when you open up PowerPoint and you say you want to make a new slide and the bullets default, what should I do? Should I default to the most common one that I found on the internet over the last year, which happens to be a triangle? Or should I default to the most common one that historically has been there, which is a circle? Or the most common one
default to the one that I use most commonly in my presentations.
Or do I default to the one that you use, which happens to be a square, right? That's what we're trying to figure out with AI, what to do. And so when you think about small data model AI, I'm saying I don't really care about what the rest of the world is doing. What I care about is what Mike is doing. What Mike always uses a square.
Right.
Why don't I bias my answer toward a square? And if you think about...
so that I'm a small model. The world of all presentations might be a medium model, but any kind of communication or any kind of bullet point in not just PowerPoints, but in documents, in movies and everything else, that might be large model.
Yeah, and large, you're getting into, tens to millions of documents being searched and indexed and used as part of the data collection, versus, 100,000, 200,000 might be your medium, and anything less than that might be considered a small.
Okay, so when you have that much data, and obviously, picking the right bullet point for a new slide, I mean, there is no such thing as a right answer. I thought computers were really good at things like math, where you have a decidedly correct answer and then everything else is a decidedly incorrect answer. You're asking AI to deal with a lot of ambiguity, which isn't necessarily a computer's strong point, is it?
Well, it's actually, you're right. It's actually, this is the part that people get really confused about AI in general. So to separate out for a second, math, what you just said, is based on a set of rules, and everyone knows what the correct answer is. 1 + 1 = 2. And everywhere you go in the world, 1 + 1 = 2. And we do that because we have rules of math, and we all learn the rules, and we follow the rules. AI is not following a rule because there's no rule that AI is doing. What AI is doing is say, observe what you see in nature, or observe what you see in the data set, and find the most common patterns, and then take those patterns and stack rank them and say, I see a lot of people say 1 + 1 = 5. And I see a lot of people say 1 + 1 = 7. And I see a smaller set of people say 1 + 1 = 2. So based on what I see in the data set, 1 + 1 = 5.
That's fascinating. So this would explain an article that I read about how ChatGPT is actually getting worse at math. I've got the story here, and apparently in March of 2023, it started out answering a simple math question correctly only 98% of the time, which is appalling considering that I think of ChatGPT as a computer and it should be able to get that right. But yet by June, it was only getting the question right 2% of the time. How can a computer get worse at math? How can it get math wrong?
The more data it has and the more it tries to learn across the data, the more examples it's taking in. And since it's at the most simple way of thinking about it, AI algorithms are about the most common occurrence, or whoever votes in the most popular wins. So I'll give you an example that's not math. I'll give you an example that's spelling related, just because it works into this. So when I was working in the spelling systems, we were using a traditional AI approach, which means that we had discrete algorithms that would check the spelling of a word. We'd look it up in a dictionary. We'd check if it has a word that's misspelled, that's common, that's next to the item. We look to see if it's called a confused word, like the word blue. There's multiple ways to say blue or there, right? And we would look at that up, and we could definitively say with proof, you spelled the word pharaoh wrong, because we looked it up in the dictionary and you used the wrong spelling of pharaoh. And what my reason I'm calling this out is because we had evidence and we had proof, and our algorithms were based off of facts.
Pretty black and white.
We switched over to do an internet-based spelling system where we went and we searched the entire internet, and it's called n-grams, but we looked to say what are the most common groupings of words together. And it turns out that the word pharaoh, spelled incorrectly, is more common on the internet than the correct spelling. Now, you might ask, why is that the case? And it's a silly case, but there was a famous horse in a horse racing a few years ago, and its name was Pharaoh, but when they registered the horse's name, they spelled it wrong. And so the horse's legal name was the incorrect spelling of Pharaoh. When I search the internet, there are more articles about the racehorse Pharaoh recently in the news than there are about the Egyptian pharaohs.
Well, this is kind of terrifying, Mike, because, I mean, if AI is only going to be, I mean, you've got these huge, large language generative models out there, and, ChatGPT and Bing. And if they're only as smart as the internet is, well, I mean, come on, we know how smart the internet is.
Yeah, and what plays with this is that they're trained on the internet. And what's assuming is the concept of mass numbers, but they're assuming that if you have a vast quantity of data, it's okay to be incorrect, because over time, in a vast quantity of data, the correctness will come out. And these are things that you see will work out in general concepts over a large set of data sets over time. But it makes a very different thing if you're thinking about trying to be precise, or you're trying to be correct, or you're trying to make an actual decision that has a lot of consequences associated with it. Because the internet, you can't
Pharaoh
trust.
may get replaced as people lose interest in the horse, and more people are interested in, who's buried in the pyramids.
Yes.
We get more correct spellings of Pharaoh in the internet. And it corrects itself? Yeah.
Yeah. So the idea is that it starts off correct. It gets bad because everyone is talking about the racehorse. So suddenly the AI system changes its mind and actually is wrong for a while. And then that fad goes away and it comes back again. Here's the thing for you to think about is, if you're trying to be correct, if you're trying to use this for a life and death decision, or if you're trying to use this for something that has a significant impact to somebody, do you want to base your result on something that is based on trends? Like, if you think about the most common story on the news today, or the most common story on one of your social media sites today, if you assume that was correct, and you made policy decisions based off of that, or you made life and death decisions based off of that on the whim of the day, I don't know. That makes me kind of nervous.
It does. Now, this is the concept that's known as data drift, isn't it? As your data changes inside your data model, all of a sudden an AI that was perfectly accurate when we launched it in March may not be accurate at all anymore in June.
Absolutely.
So you got a couple of choices here. I mean, if we're looking at using AI to inform healthcare decisions or law enforcement decisions, either we've got to get away from a large data set that we don't control, or we need to have, can we do this with smarter algorithms? What are the solutions to data drift?
Yeah, a couple things. One is recognize that data drift exists, and you make a decision if you want it or not. And here's why it sounds strange. Data drift, when you start with it, you're like, well, I don't want my data to drift. My answer is you probably do. For example, working with an outdoor retail company that you might be able to guess what, but if you think about, they sell products for camping.
Mhm.
If it's January and I'm building a model on what are the most likely things to put on their web page on sale, I'm probably not going to put swimsuits. Right?
True.
If it's June, I'm probably going to put swimsuits and beachwear, and I'm probably not going to put parkers. We're actually
So as long as my algorithm knows that we're getting seasonally adjusted results, then we're good. But if I ask for what the most popular product is, and it just happens to be a 6-month gap between my asking it, I'd better be okay with different results.
Yeah, and this goes back into when you're using these tools, and AI is just a tool. It's not correct. It's probability based. It's trying to find you the most likely answer to your question, not the correct answer. So
It's not correct. It's popular.
It's popular. So if I'm doing outdoor goods and I'm now in March and you hit the site, what do I do? Do I do parkas because it's still kind of cold and people are searching for parkas, or do I do swimsuits because I know summer's coming up? I have a hard time if I'm an AI system.
So there's no way I'm going to let AI look at the internet today to do my purchasing for 4 months or 5 months from now, because it will be wrong.
It will be wrong. AI is always wrong. The question is to what degree? And this is why it's interesting to think about that. Everyone's like, oh, it's AI, it must be perfect. AI is never correct. It always comes back with a set of results. It will give you an answer, and then it will give you what it thinks the confidence value of the answer is. So it will say, I think that you should go and buy a swimsuit. I am 20% okay with that. Or I think you should buy a parka. I am 80% okay with that. And people talk about this accuracy, and they're like, it's 80% accurate. It was like, that's really cool. But anyone step back to think about, that means it's 20% wrong. And so it's better to start talking about it.
1 in 5 chance of being incorrect. That's, yeah. Okay. So we've got data that's moving around underneath us. How often does the algorithm change? I mean, we've got data drift. Is there such a thing as algorithm drift?
So on the data drift, and to play into it. So usually you write an algorithm, you feed it data, you do some type of evaluation, which I think we should get into in a second. After you're done evaluating it, you then use that model and you ask the model questions. That model then is already pre-trained on a set of data. So that model will give the same results for the same input forever.
Because we've got static data.
Because it was trained, and the trained data is what actually generates the models from that. So now you got a problem, and people would build a model, a year or two ago. It takes a lot of effort to build a model. They get the data all in, they build a model, they ship the model, and then their customers are going to come back later and say, hey, it's giving me the same answer it gave 6 months ago. It's not getting smart. And everyone's like, ah, crap. What you want is a learning model. Okay, what we'll do is we'll train the model again. And so now I trained the model 6 months ago, I trained it again today, and now I have a model that is different, didn't say improved, different than the previous one. I don't know if it's better or worse. And this is the thing that people forget is every time you train a model, every time you get a new model, it actually could be worse than the previous one.
So where is the how do you know answer?
That's what people forget. It's how do you evaluate the models to see if you should use it or not. Everyone just jumped up on ChatGPT and said, hey, I'm going to use this to write an essay. Isn't this cool? It's kind of neat, right? But they didn't actually step back to say, should I use to write an essay or not? It's more of a fun tool, and you can play around with it. But it kind of goes back into, are you actually thinking not again of I want to use AI, but how do you check AI to see if it makes sense or not?
How do you make sure the references it put in my essay actually exist? Couple stories about references in ChatGPT generated content that the references didn't actually exist.
Oh, I love the chat with ChatGPT because it just the easy way I say it is it lies. It has no qualm lying and just making up some type of fake answer because it's job in life is to answer, not to be correct. And so it will always answer. It's kind of like when you're talking to a child in your family, and you know that they're a big fibber and a storyteller, and you ask them, well, why'd you do this? And they give you an answer. And then a few minutes later, you ask, why'd you do that? And they give you a different answer. And the stories just get more and more different from each other, right? That's all that ChatGPT is doing. Is its goal in life is to answer a question, not to be correct. So an example of this is I'm talking with ChatGPT just for fun on a subject I quite know well. And it's about some people that I personally know and their history and things like that. And I start asking questions, and it's giving me lies. And it says, well, this person did this on this particular date. And I'm like, excuse me, but they weren't born at that period. Oh, I'm sorry. I was wrong. What I meant to say is like, no, you were lying. You just made this up, right? And only because I'm a deep expert in the area I was asking questions could I detect that it was lying. Everyone else would have believed it.
So I mean, there's a difference between kind of an entertainment or recreational AI, ChatGPT. But we've got clients who are looking at using AI in considerably more commercially viable applications like healthcare and law enforcement.
Yeah.
We can't have this kind of data drift, or we can't have this kind of model uncertainty. I still think that AI makes sense in healthcare and law enforcement, but does it just mean that we have tighter control over the data, that we have objective standards or metrics by which we judge the success of a model? How do we make it usable?
And you used the magic word in there, judging. So what you do with a model is you have to figure out how are you going to judge this model, and determine if how we, in the training process, you have to train it, and then you tell it, here's a good answer, here's a bad answer, it trains again, here's a good answer, a bad answer, it trains again, and it's trying to get closer to the good answers, right? Somebody has to be involved in the training part to be the judge. And things are very subjective in the world. 1 + 1 = 2. Okay, we can say that's a fact-based item, but a lot of times things are subjective. And so you need to figure out is how do you deal with subjective-based results?
How do you tell the difference between a question that should be fact-based math and a question that should be open for interpretation? Yeah.
Then this is an area where a lot of the AI today is I think poor in its algorithm approach. They've chosen to use subjective and closest answer as the way to go about popularity answers, rather than saying, let's use facts first. And when facts are not understood, then we can use popularity and tell the user the popularity is the way it came about it.
Okay, so actually making coding the UI to disclose how it came up with the answer actually takes a lot of the curse away from it, because it says, hey, these are not from sources you have told me are tomes of truth in the universe, math, right, for example. This is what I think might be correct because I've pulled this from decades of social media posts.
Exactly. And you can think about how an answer could come back and say, sorry, Mike, but I think you're using the wrong word in this sentence. I checked that word in Oxford Dictionary and Webster's dictionaries, and they both agree that this is the proper word choice. That's fact-based.
Yeah.
It'd be different also to say, Mike, I read your sentence and I don't quite understand what you're trying to say. And I checked all the dictionaries around in encyclopedias, and I can't find any references to that the way you're phrasing this. But I did go on the internet, and I found on Twitter 4 months ago, there was a set of people who were associated with beach going in San Diego, and they happen to use the same phrase. Is that what you're trying to mean? Very different way of talking about how you come up with the facts to explain the results.
So why doesn't more AI work that way today?
Because none of the algorithm generators care about that. The problem with AI today, all the large language models, all the AI research areas, is they are obsessed with popularity will solve the problem. If I have a large enough data set over time, it will correct itself. So I don't need to be accurate today.
Crowdsourcing will always be right, in other words.
And this goes into, it works out just fine if you want to play around and talk about, well, what's the, what are the top 10 music choices of the decades? Like, it's a subjective thing. It doesn't really matter, and everyone can have their opinion on it. But as long as they're like, one of my favorite songs is in the top 10, I'm like, okay, fine, it worked, right? If I'm trying to make a critical decision, I need to have the evidence points behind it to know about it. It kind of, you mentioned law enforcement. It kind of goes back into, if you're going to bring an expert witness into a conversation, or you're going to bring someone that was a witness to a particular event into a conversation, you want to understand their credibility.
Yes.
No one does that with AI today. They'll just throw an expert witness up onto the computer screen and have no conversation about their credibility or their ability to repeat themselves in a consistent way with the same in the same domain knowledge area. And they'll ask a simple question that's open-ended and subjective, and then just believe the result. It's like you randomly walk down the street, you grab someone, put a microphone in front of their face and says, "Hey, can you tell me the origin of the universe?" And they'll say, it came out of a Big Bang. Everyone's like, "Oh my gosh, the Big Bang, that's it." And it's like, well,
it sounds like a late night television sketch, All right, so I've got some doctors, and they're in the business of taking a look at radiological imaging, like X-rays and CT scans and stuff like that, and they're looking for lung cancer. Yep. And they're trying to evaluate all of these scans for, can we detect lung cancer early? They're thinking AI can learn how to do that really well. If you give them enough information about every patient ever, who's ever had a scan ever, and whether or not they've gotten cancer ever, AI should be able to figure this out. Is that a reasonable ask for AI today?
So yes, because you added a couple of qualifying statements. You said, could it eventually figure it out? Can it eventually get there? As soon as you add those words to it, I can say, well, sure it can, and we should explore. Let's back up for a second and say,
can it today?
Today changes that conversation just a little bit. So let's think about this. I happen to one of the things I work on is we're doing lab result image processing for a particular area that I'm interested in. I'm helping out a company with, and so we're looking at blood samples. And we're looking at the color of the blood samples after it's been separated through a medium. And based on the color, we're trying to determine what chemical was in that blood sample. And it's kind of cool and fun and everything else. But you can imagine, normally you'd get a fancy lab test and you would go through and you would do some type of chemical analysis. And, after a week, you get the results back and you can say definitively what was the breakdown of the chemical that was in that sample that was separated out. And I'm trying to do it in real time within 2 seconds or less in the field in Africa, right?
With some sort of camera or
with some type of cheap cell phone, right?
Seriously.
Yeah. And you're like, Mike, you're crazy. I'm not crazy. I understand my limitations and I can describe my system from the limitations perspective. I'm not trying to be as accurate as a week-long process that breaks down every molecule and gives me a complete analysis of that. I'm trying to make a quick triage decision that says, should this baby be rushed to a hospital that's 3 hours away, or should the baby, stay in the local clinic or not? That's a very different style of question because at the end of the day, if the baby ends up in a hospital, the hospital will do the complete results. They'll do the breakdown, everything else. But there's no way I'm going to get the hospital into the field in order to do this. So I need something that is good enough to then have an expert review it.
True. So there's no harm if the baby goes to the hospital and they look at the baby and they say, actually, you know what, this baby's okay. This baby's not at risk.
And this is
the
the
baby
concept
doesn't
of,
end up worse for wear as a result of that. But the number of babies that you could save by getting them to a hospital in time goes up. So you've got a very controlled data set in that example. So as long as I'm not just accepting completely random x-rays, but I know that I trust the x-rays that are going into my model for looking for cancer, I may not be able to say for sure whether or not this person's going to develop cancer, but I can certainly tag it and say, I'd keep an eye on this.
right. And
today.
This is the thing that you can play with is if you go down that path, if you look at all the x-rays in the world, right? I actually don't know this personally. I'm gonna play with it, but I'm assuming there's probably a whole bunch of x-rays of broken arms and legs that are in the set of all the x-rays in the world. Right? You probably don't want to use x-rays of broken arms and legs when you're trying to develop a system for lung cancer.
Absolutely.
Somebody has to start making a decision on what to include or not in the data set. So you have to accept from the very beginning that your data set is actually curated. Right? And it's logical to say x-rays of arms and legs don't make sense in that. Okay, fine, I'll agree with that. Now let's talk about x-rays taking of, I'm not a doctor, I've never done a chest x-ray, but I'm assuming that when you do a chest x-ray, you actually want the chest as part of it. Okay. How many x-rays of the chest are perfectly framed?
And does the angle make a difference? Does an arm in the way make a difference? Yeah. So if we're going to look at curated databases for AI for life critical applications of AI like healthcare and law enforcement, who is qualified to curate that data? Do you need a law enforcement officer? Do you need a medical specialist to be doing this? Because I mean, you're asking a lot here. What I'm hearing is, I've got to be an oncologist, and I've got to be a computer scientist and a big data expert.
You can break this up into different people can do different aspects of the role, but let's use this X-ray curation area, an area I've never done personally, but it's kind of fun for us just to talk about for a second. If we agree that we probably don't want arms and legs in our data set for training on X-rays for chest issues, okay, fine. Someone has to be part of that filtering process. That's a judging process. Now, a couple ways you can do it. The first way people do is it's called labeling, but you say, you know what, can I actually use the metadata associated with this x-ray to help me on this? And can I trust that the hospital, when they took the x-ray, that they tagged it and said, this is a leg. And so let me throw away all the legs.
Gotcha. Okay.
Right?
So by adding a lot of metadata to all of the data in our set, each person who's an expert on this particular piece of metadata can add their expertise along the way. And you don't need one person who's an oncologist with a degree in computer science.
That's right. And if you think about one thing that a lot of the new AI models do is they're actually not doing the final step of the AI. They're actually doing metadata tagging. So in the x-rays, let's say that X-rays, I'm assuming that there's a small difference in the quality or fuzziness of an X-ray. Okay, could I write an AI model that it's called a classifier and it can group things, and I can then say, I would like to group all of the high focused, in focus X-rays together into one data set, and the fuzzy X-rays, the ones that are out of focus, I'm going to throw those away. Now,
interesting.
From the very beginning, I'm saying that I'm already biasing my data sets because I've already chosen just to look at the ones that are in focus pictures, right? So every time we do this data filtering, this curation, we have to acknowledge that we're purposely biasing our data sets through the filtering process.
This is a huge invitation for your database just to get phenomenally messy.
Yes, it goes the other way. The invitation is it becomes what's called overtuned, because I threw away the fuzzy. And then the next thing I'm going to say is, well, let's look at X-rays, but I only want X-rays where the image fully fills the frame. Okay, and so if the image was a little bit too far away, it was unfocused, but didn't fully fill the frame, I'm going to throw that away as well. And so now I've overfit my model to x-rays that are perfectly framed. Then my next question comes into, well, I want to do ones where I can identify a landmark. And so you can write an algorithm that says, can I see a particular landmark? Let's say I can see a collarbone, right?
Mm-hmm.
Now I've overfit my model to x-rays that have collarbones. So at the end of this process, what you're going to say is, I can predict, and you walk backwards, this type of cancer that is of this particular size in this type of x-ray area that had these type of landmarks that was in this type of resolution that was in, you walk the chain backwards and you classify and say, this is what my model can do.
It's interesting because it sounds like we're approaching the problem that we have in a lot of studies in which you throw out all of the data that doesn't meet the conclusions that you came in the door with.
Yes. And it's okay as long as you accept that's your premise. It's kind of like when you're doing a laboratory study.
So if you're looking for a brand new kind of indicator to show cancer, one that nobody's ever seen before, and AI has decided that if you have a particular shadow on a certain scan, and it is in the same patient who has a CT scan that looks like this, nobody's ever put that correlation together before, but there's a super huge correlation between that and developing cancer in 7 years, 7 to 10 years. I mean, that's what we want to find out. But if we're throwing out all of the data that doesn't meet our preconceived notions, we might be throwing out some of the data that has these irrelevant shadows on it.
Exactly. And this is where people, your point was right, is if you think backwards from the result through the data set and you clarify that statement, it makes it a lot easier to have a interesting conversation about how much I can trust this item. The way you're talking about a new type of cancer is, can AI find a new type of cancer? No, AI can't find new anything. What it can say is, I don't know what this is, because the probability that this is something that I do know is low.
Interesting.
Right?
That is a huge insight. That makes sense.
And now you can say,
a lot of sense.
How do humans add value in this conversation? Is if the AI can go through the system and say, I found 4 images that I can't classify. Can you help me? And a human looks at them, and a human looks at those images and says, "Oh, this one's junk. This photo was just a test photo. There's not even a patient inside of it."
Bob's finger was over the lens. Yeah.
Yeah. Their fingers over the lens. And then this third photo, however, this is interesting. I want to read about this patient, or I want to see this patient. Right? If we think about AI in this triaging aspect of things, it's a little bit more interesting. Again, this goes back to the conversation we're starting with, is popularity. Popularity is really cool if you think about the flipping of that, is what is unusual or what is different than popularity. I want to look at the exceptions.
Interesting. So this is not so much a question of should we use AI. It is absolutely a question of how we use AI.
Yeah, you can imagine, pop back and forth between your doctors and law enforcement, but you could say, hey, I found a fingerprint, and can I search all the fingerprints in the world? And it comes back and says, yeah, it's an answer. You're like, okay, that was clever. It was just a database lookup. I know it's hard, but it's still interesting. Wouldn't it be more fascinating if it says, hey, I've never seen this before. And because I've never seen this before, I think we need to do more analysis of it. Right?
Yeah.
It could be wrong, but that's what we kind of want. If you think about an assistant should be giving you that type of insights. People get confused because they think that AI is not the assistant, but AI is actually the authority. No, it's not. AI just lies. And I love the fact that they use the word for AI lying. They call it hallucinating. Now, I think that word is wonderful, because let's go back to your medical word for a second. If your doctor was hallucinating when they gave you the diagnostics, how would that look in a lawsuit?
In the malpractice trial, it wouldn't look so good.
And the fact that we use the word hallucinating as the way to describe when AI just makes stuff up, right? It goes back to think about that for a second, right? I use the word lie because I think it's a little bit more blunt, because for some reason people don't have the issue with hallucinating. It's like I do, right? I don't want my autonomous car to be hallucinating while it's driving down the highway. right? I don't want my law enforcement decisions to be based off hallucinations, nor my medical decisions.
Right.
But flip it for a second. When we're doing medical and someone's going through residency, right? On day one of residency, the doctor that's overseeing them, how much do they actually trust a resident's statement?
Oh, they double check everything and they correct the residents when they hallucinate problems that don't exist or don't see ones that do. I mean, that's why you have a residency program, right?
So why don't we consider the same thing for AI?
It's supposed to be smart out of the gate because we've given it every X-ray in the world, and therefore it should learn and it should know. That's what everyone writes about. When they write about AI solving humanity's problems or being the end of humanity, it's always based on some aspect of that. Yeah.
Yeah, but imagine if you flip the conversation and say AI is a permanent resident in training that sits right next to you. You can say, "Hey, what do you think, resident?" And the resident gives you an answer, and you're like, "That was stupid," and you ignore it. Or the resident gives you an answer, it's like, "Yep, that's what I was thinking too."
That's a brilliant way to look at it because one, all of a sudden, you and I aren't going to have to worry about our jobs thanks to being replaced by AI, but we'll have an assistant with us. Doctors will have an assistant with them. I mean, it's going to take a lot of wind out of the sails of the Skynet folks, but
it all goes back to what we choose to do with the results that AI is giving us. If you think AI is authoritatively correct, the oracle of all knowledge, right, you're in for a life of hard learnings because 1 + 1 does not equal 7. Right? If you say that AI is simply an assistant and it's giving you its best understanding, and how you ask the question changes the response, then you can do it. So if you asked AI, what's the likelihood that this image is the same same as a category we've seen before? And it comes back and says, very unlikely, never seen this image before, right? You have to do a computer voice, that way people can believe it, right? You're like, hey, that's interesting, I want to look at it, right? It was like, high probability, it's 92% the same as all the other images in the same data set, right? You're like, okay, that's cool. I need to be able to have that type of understanding on top of what AI is giving you so you can decide. We're doing the medical thing, back to my image processing that I'm doing for the doctors in Africa, right? So I have traditional AI algorithms. I have traditional manual algorithms that are calculating these chemical results. And I'm pretty good. We take it out. We're plus or minus 0.1 what a lab standard would be for a similar thing. Wow. So we're like, hey, we can be better because let's use AI. So we build out all these AI models and we do the image processing on it. And it's a small data set because I only have thousands of samples rather than millions, right? And AI comes back at 80% correct. And my AI engineers are like, hey, let's ship it. And I'm like, 80. Wait a minute. My manual process is 99.9% correct. AI is 80. No, I'm not going to use AI. Right? Like, but it's easier. No, it's not. It's not as good as. You have to have what's called a guardrail. And a guardrail says, when I have a question, I give a standard question, I give something, right? Do I get the expected result as a minimum bar? And this is critical because everyone is excited when they get the confirmed positive result, right? Mm-hmm. But it's the false negatives and the false positives are what you actually have to look at. Because when you evaluate the goodness of a model, it's not about how many times it tells you that 1 + 1 = 2. It's instead, how often does it tell you that 1 + 1 = 5?
Yeah. Yeah.
And you have to talk about that frequency of incorrect to decide if it's worth doing or not. So
can those guardrails be digital and baked into the algorithm, or should those digitals be something completely separate against which you check the results?
If you have a test data set that has known, this goes back to think about earlier, we did filtering to filter down to get where we're looking for, right? Mm-hmm. All that stuff that I threw away during the filtering, I should bring back into the guardrail test and I should give it a picture of a leg and say, what do you think? And if it comes back and says, oh, that's 99% correct, that person has cancer, right? You're like, wait a minute. What do I do with this thing? Because it's not, if you're doing the police enforcement, right? and you give it a case that you know is ridiculous and completely incorrect, and yet it comes back and says, "Oh, I would recommend we should, investigate that person further." You're like, you can't trust this system because it's false negatives, right? I have too much of an impact or too incorrect. So what I do when I build my systems is I start with what are the guardrails that I need to ensure are met. After I meet my guardrails, then I can say, does AI give me a benefit on top of the guardrails? The way to phrase this, and you're mentioning doctor, so we'll go back to it.
Mm-hmm.
We forgot the word do no harm.
Yeah.
The first thing you need to do is ensure that AI does no harm. And then you can talk about, does AI provide a benefit?
So if we're going to leave our viewers today with sort of 3 key takeaways from this, it seems to me like one is AI hallucinates. It's going to give you what it believes is the most probable answer.
Popular.
That's the first thing. 2, because of data drift and because these things happen, you need to deliver all of your AI generated results in the context of which they were derived.
Mm-hmm.
So from this data set, looking at this, I believe that these things are true so that the human can interpret that and decide whether or not your AI is hallucinating. And third would be, make sure you've got guardrails set up so that if your AI starts going off the tracks, you don't end up going over the cliff in a horrible fiery crash. You can actually go ahead and catch that, and then I guess work on fixing your model or your data drift.
And what I find when I work with teams is teams are so excited to build the AI and to use the AI that they never asked what was the data that was excluded in building the model, what was the filtering we used, because that's bias, into the model, and then what were the guardrails that we use to determine does the model do harm?
Mike, this is going to create an entirely new kind of employment classification. AI data management is going to become a huge job requirement in the next 5 or 10 years. It's going to be
absolutely
great.
Yeah, absolutely. That's what you do today is you hire teams of not data scientists, because data scientists come up with the algorithms. You hire teams of data analysts who are helping you manage these data sets and do the processing on these things, right? And as we always say, data in, data out. You put junk in, you get junk out. It all comes back down to understanding that data. If you don't understand your data, then you really don't understand what the results are.
That's fantastic. Mike, thank you very much for your time today. I've actually learned a lot about AI, data, and how they work together, and how to use AI more productively as opposed to just sort of the blind trust that that gets written a lot about in articles and papers. Thank you.
Yeah, it was a blast. Thank you very much.